Hi, today we're going to be learning about representing data. We're going to be doing a quick review of all the different types of graphs that you should already know. The first one is bar graphs. A bar graph is a graphical representation of data using bars of different lengths to show the frequency of the data in different categories or groups. Bar graphs are used to represent discrete data. This is data that can be counted. Here's an example of a bar graph. There are certain rules that you need to follow when you're drawing a bar graph. The first thing you need to do is make sure that everything is labeled. Your graph needs to have a title, and the axes need to be labeled, and all of your bars also need to be labeled. Then, you also need to make sure that you have gaps between the bars. Bar graphs must have gaps in between the bars. Then everything needs to be consistent. You need to have consistent scale intervals. Over here you can see I'm counting in twos consistently, and the size of the gaps over here between them are all the same, so it's consistent. You need to have the same width bars. All of the bars need to have the same width with each other, and the gaps need to be the same size as well. So you need to make sure that everything is consistent. You can also draw bar graphs representing two or more sets of data. The first type of bar graph that we can do this with is a double bar graph, where you have bars grouped like this next to each other. So here I've got class 1 and class 2, and I'm comparing how many books class 1 read compared to class 2 in each of the months. Okay, so you can see I've got class 1 and class 2. Here you can see class 1 read less than class 2, and here you can see class 1 read more than class 2. So here you're able to compare different classes or different groups of data next to each other like that. This format can also be used for more than two sets of data. You can have 3 bars or 4 bars next to each other, depending on how many sets of data you are representing. So you can have any number next to each other. You can have a triple bar graph or a quadruple bar graph and so on. Okay, then the other type of graph we can draw to represent two or more sets of data is a compound or stacked bar graph. This is one where the two sets are stacked on top of each other, and this allows us to see the total as well as seeing how the two contribute to the total. So over here I can see that the total number of books read by class 1 and class 2 is just over 80 for February, whereas over here it's easier to compare them to each other, but I can't see what the total is without actually adding them up. Okay, so there are different reasons for using the two different types of bar graphs. You've got the double bar graph that allows you to more easily compare them, and you've got the compound bar graph or the stacked bar graph, which allows you to see the total and still see how the two or more sets of data add up to that total or contribute to that total, but you can't compare them quite as easily. Okay, so that's the bar graph. Next we have histograms. A histogram is a graphical representation of data using bars of different lengths to show the frequency of the data divided into intervals. Histograms are used to represent continuous data, which is data that can be measured. Continuous data can include decimal values. Okay, so here's an example of a histogram. Just like when you are drawing bar graphs, there are certain rules that you need to follow when you're drawing histograms. You need to make sure that everything is labeled, so you need to have a title, and the axes need to be labeled as well. Then in a histogram, it's different to a bar graph because there are no gaps between the bars. So for bar graphs, there must be gaps. For histograms, there must be no gaps. And you need to make sure that everything is consistent again, just like for bar graphs. You need to have consistent scale intervals on your vertical axis, and you also need to have consistent scale intervals on your horizontal axis as well. So look over here, this is different from bar graphs. For bar graphs, each of the bars is labeled separately. But here, for a histogram, because it's continuous data, we don't label the bars themselves. We've got a scale over here. In this case, it's counting in tens, and the bar is between the numbers. So this bar is representing all the numbers from 0 to 10. This one is representing all the numbers from 10 to 20 and so on. So for a histogram, your scale interval over here also needs to be consistent. Okay, then for histograms, we also work with intervals. Intervals for histograms are slightly different from intervals for bar graphs because histograms are used for continuous data, which can include decimals. So you can have intervals for bar graphs, but they will not include decimal values. So you'll have intervals like 0 to 9, 10 to 19, 20 to 29, and so on. For histograms, the intervals are normally written like this, where it says that x is between 0 and 10, and it can be equal to 0. And then here, x is greater than or equal to 10, but less than 20. Here, x is greater than or equal to 20, but less than 30, and so on. So you're being given the interval so that it can include decimal values. Just please be aware that you can have histogram intervals being presented to you in the same way as bar graph intervals if the data that you're working with only includes whole numbers. So if you're working with marks and everyone's marks is a whole number, then you can be given the intervals like this, even if you're working with a histogram. So just be aware of that, but normally histograms would have intervals like this. Okay. Next we have broken line graphs. A broken line graph is a graphical representation of a variable changing as time or a different variable changes. The graph is made up of points representing the different data values. These points are joined together by straight lines. Broken line graphs can be used to see trends and patterns, providing a means to make predictions. And you need to note that broken line graphs are not the same as straight line graphs, which are drawn using an equation. Broken line graphs are not drawn using an equation. Right, so here's an example of a broken line graph, and once again, there are certain rules that you need to follow when you're drawing this. The first rule is you need to make sure that everything is labeled. Just like we had for bar graphs and histograms, everything must be labeled for broken line graphs. So you need to have a title, and your axes need to be labeled as well. You need to make sure that your scale intervals are consistent on both of the axes. And you need to make sure that your points are joined by straight line segments. Next, we have pie charts. A pie chart is a graphical representation of data using a circle divided into slices of different sizes to show the fraction that each category or group represents out of the total data set. So here's an example of two different ways of drawing a pie chart. Okay, first you need to make sure that your pie chart is labeled. There must be a title. Okay, then you need to make sure that the slices are labeled. Now this can be done in the form of a key like this. If you're using colors, it's easier to do a key like this. Or if you are drawing it in black and white, then you can label the slices themselves. Just be aware that it can be difficult to fit everything in, to fit the labels in if the slices are small. And then you need to make sure that the percentages are filled in as well. In order to do your calculations, you need to know how to work out the percentage and the angle for when you're going to draw your pie chart. So to work out the percentage, we take the category value and divide by the total. So if there were 10 people who preferred apples out of a class of 30, it'll be 10 over 30. Okay. Then you multiply by 100 to work out the percentage. And to work out the angle, we do the same thing except we multiply by 360 instead of 100. For percentages, we multiply by 100 because percentages are out of 100. For angles, we multiply by 360 because a revolution is 360 degrees. Okay, now we're going to go on to an activity. In this activity, you're being told that a group of 60 learners were asked about how they got to school, and the results are shown in the table. So there were 30 learners who said they walked to school, 6 came by car to school, 3 went by bus to school, 15 rode their bicycles to school, and 6 went by taxi to school. So in this activity, you're going to represent this data in 2 different ways. First, you're going to represent it on a bar graph, and I'm going to give you 3 minutes to do that. Okay, so let's go through that and see what you should have got. So this is what your graph should have looked like. You should have your title, you should have your labels for your axes. Your bars all need to be the same width with gaps of the same size. You need to have a consistent scale on your vertical axis over here. So over here, I was counting in 3s. You might have chosen differently, and that's fine if you did. You need to make sure that all your values are correct. So over here, for walking, it goes up to the 30. For car, it goes up to the 6. For bus, it's 3. For bicycle, it's 15. And for taxi, it's 6. So that's what you should have got for your bar graph. Right, now you're going to go and represent the same data on a pie chart. First, you need to fill this table in. You need to complete the table to work out the values so that you can then represent it on your pie chart. So I'm going to give you 3 minutes to complete the table and do the pie chart. Okay, so let's go through that quickly. Okay, so first we had to complete this table. So the total number of learners was 60. Okay, and we need to know that for when we're working out the percentage and the angle. So first, to work out the percentage of walking, we take the 30 over 60, we times it by 100, and that gives us 50%. Then for the angle, it's again 30 over 60, but this time we multiply by 360, and that gives us 180 degrees. For car, it's 6 over 60 times 100 gives us 10%, and then 6 over 60 times 360 gives us 36 degrees. For bus, 3 over 60 times 100 is 5%, and then 3 over 60 times 360 is 18%. For bicycle, 15 over 60 times 100 is 25%, and then 15 over 60 times 360 is 90 degrees. And then finally for taxi, we have 6 over 60 times 100, that is 10%, and then 6 over 60 times 360 gives us 36 degrees. So now you have to use this information, the angles, to actually draw the pie chart, and then you have to fill in the percentages once you've drawn it. Okay, and then this is what you should have ended up with for your pie chart. So first of all, you have to make sure you have a heading, a title for your pie chart. Make sure that each of your slices is labeled and the percentages are written in as well. And just make sure that they look like they're the same sort of size as what mine are over here. Now you've drawn two graphs representing the same set of data. You drew a bar graph and you drew a pie chart. So let's just quickly point out a few things that you can see in the two different ways of representing it. So in a bar graph, you're easily able to compare the different categories to each other. You're easily able to see that this is more than all of the other categories. You can easily see that this is the least out of all the categories. You can see easily that these two are the same as each other because they're the same height as each other. If you look at the pie chart, it's highlighting different information. The pie chart makes it easier to see the proportions. You're able to see more easily that this is half of the full set of data. You can't see quite as easily that these two are the same if those percentages were not filled in. If they are filled in, then you can see that they're the same. But it's not as easy to see if you haven't been given the percentages. So the pie chart and the bar graph have different strengths and different weaknesses. They show us different things. They highlight different things for us. Now we're going to go on to the last activity for today, where you're going to practice drawing a histogram. So you've been given a table with the heights of learners in centimeters, and you need to represent this data on a histogram. I'm going to give you 3 minutes to do this. Right, let's go and see what your histogram should look like. So this is what your histogram should look like. You should have a title. Your axes need to be labeled. You need to make sure that you have consistent intervals on both of the axes. For the vertical axis, I was just counting in ones. But for the horizontal axis, I was using the intervals that they gave us, which was 120 to 180, broken up into intervals of 10. And you can see over here, I did a zigzag to show that I was leaving out numbers between 0 and 120. Remember that your histogram must have no gaps in between the bars. And you need to obviously have them all going to the correct height. So that's what your histogram should look like. And that is how we represent data using bar graphs, histograms, broken line graphs, and pie charts. Now that we've learned the concepts in this lesson, it's important to practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.